the area that says pencils down, it just says pencils down because I want you to pay attention first. So this is actually going to relate to number 4 from yesterday's paper. Some of you got there and some of you didn't. But it basically displayed a triangle. And then it was labeled triangle ABC. Now, not every triangle in the world is labeled triangle ABC, okay? But this formula uses A, B, and C. So something you have to be aware of before we start coming up with these formulas is the fact that A, B, and C are kind of arbitrary. They could be anywhere, right? Even if someone gives you triangle ABC, if they're located in different spots, you'd kind of have to adjust our formula. So instead of memorizing it like A always goes there and B always goes there, memorize it like, oh, it's those two sides and this angle, kind of like where they'd be oriented on the triangle so that the names don't mess you up, okay? So you guys were given triangles like this yesterday and asked to find the area, and they were not right triangles. So what did we do in order to help us find the area? Like in problems 2 and problems 3 on your handout yesterday, what did you have to do to try and find the area of the triangle? Okay, either change the base, so we know that we could rotate this triangle kind of however we wanted to make whatever was useful the base. And then what did you have to physically draw in there? The height, that make the right triangles in between, right? So we drew something in that we called the height, okay? So in this triangle, usually they name the sides of the triangle across from their angles. So like if this is angle A, they would name this little side A, and if that's angle C, little side C, and if that's angle B, this would be side B. And then we know this whole thing is B, but we don't really know how that's like split up, right? We learned that yesterday when we did it. So if those of you that got to number 4, this was the challenge. You guys know that area of a triangle is 1/2 base times height, right? And the way that we drew the triangle right now, if this is what I'm calling my height, what is my base? Little b, okay? So if I were to write the formula right now, I would write it like this. But here's what I was asking you guys to do in number 4, those of you that got there. Basically, replace this. Replace this so the person that comes after you that has to find the area of this triangle doesn't have to draw in the height and do all this math. Do all the math for them and just give them something right here that if they memorize, they could just plug stuff in and find it. They don't have to draw the height and figure it out through thinking, per se, okay? So how did you guys find this height? Like in number 2, okay? When you guys drew in the altitude yesterday and you were working, what did you use to figure out this height here? Okay, so they said they either used angle C or angle A in this case? Yeah. Okay. Or angle A. Did you guys find yourself doing that? That once you drew this, you kind of looked at one triangle, okay? If I were to try and find H using angle C on this side, I would also be using side A, right? And I would say, what trig function would you guys use if you were using H and A? Sine. So I would say the sine of angle C equals H over A. And then how did I solve for H? Times it by A. So this looks a lot like the work that you guys did yesterday on your paper, right? A lot of you guys will have this same exact work. So this says that the height is actually equal to this little formula. If you gave this formula to somebody, they wouldn't have to draw this and figure out themselves. They would just take the numbers around the edge of the triangle and plug it in. That's basically what we're saying. So if I plug this in for H into my formula, I get an area formula that says the area of the triangle is 1/2 side length B. And then instead of saying times H, I'm going to plug in all this stuff that's equal to H. So times side length A times the sine of angle C. Okay? So you might think, like, that's not helpful, that's complicated. I agree with you. So if I don't remember this formula, could I figure it out on my own like you guys did yesterday and draw stuff in? I could, okay? What's useful here is somebody doesn't have to do that work if they choose to remember this formula, okay? But some people didn't use this side, right? Some people used this side, okay? So if I was using this right triangle over here on the left side of the diagram, then what is the formula that I would have written to find H? So if you're using this triangle over here, Well, we don't know how long this part is. So this is the other side length that we know. So what angle would you be using over here? Angle A, okay? And if you want to use this piece and this piece, what trig function would you be using with angle A? Sine, okay, because it's still opposite and hypotenuse. So in this case, the sine of angle A equals h over c. And how would you solve that equation for h? Times by c. So h is equal to c, my pen will write, times the sine of A, which means I could have done something different here. Instead of plugging in this, I could have plugged in that, and my area formula would look like this. Okay. Those two area formulas work for this same triangle. There's actually a third formula that would work too, but I would have to draw the h somewhere else, like you guys talked about for number 3, where I could draw it like this, or I could draw it like this, and kind of rotate my triangle and think about a different base and height. Anybody tell by the pattern of how things are working out here? This triangle has sides A, B, and C, angles A, B, and C. What the third formula might look like? What's it going to have at the beginning? 1/2. Okay. And then look at our other two formulas. This one says do side B times side A and use angle C. Side B times side A and use angle C. Okay. This one says use side B times side C with angle A. So here's side B times side C, and here's angle A. What's the pattern in the triangle of where these things are located that I'm plugging in? What do they have in common? What's that? They each found H. That's true. Okay. So look at this one. Side B and side A were right here, right? That's what I outlined in yellow. And then the formula used angle C, which was right here. Okay. In this one, it used side B and side C, which are over here, and it didn't use angle C. Which angle did it use? A, which is right here. Mikey?
Would you want us to use side C and side A for angle B?
Good. So do you guys see the pattern that Mikey found? If you're going to use side C and side A, which angle should you be using? Angle B, the angle between them. So I wouldn't memorize this formula like, oh, A, B, sine C. It's going to be like alphabet soup, right? I would memorize it more like you can find the area of a triangle if you do 1/2. You can use any two sides of the triangle, and then the sine of the angle that's sandwiched between them. Does that make sense to everybody? If I'm using side B and side A, angle C was sandwiched between them, so that's where it showed up in the formula. If I was using side B and side C, angle A was sandwiched between them. Okay? Does that make sense to everybody? So what I want you to do is I want you to go back to the triangles from yesterday, and you're going to see if you get the same calculation that you got before. Actually, no, I lie. I have to wait till we get to a different law because these ones only give you one side law. Okay? So actually, I'm going to have you go to the next example of your note guide, but before we do, okay, so first thing, draw yourself a generic triangle to make sure you understand where everything is oriented and how it looks, okay? I have no idea if this is accurate, okay? I'm just drawing kind of the same little cheesy triangle ABC every time, okay? Just trying to put things in places. And sometimes when I figure out if I label it that my drawing looks really wrong and I feel uneasy about that, I could redraw my drawing if I wanted, okay? So side B, which means across from B, is 35. Side C, which is across from C, is 23. And angle A is 36. So first of all, if you wanted to use the area formulas that we just came up with, do you have the right combination of information? Yeah. Okay, and I don't know that because I memorized the whole ABC, ABC. I just knew it was 1/2, right? And then it was two sides multiplied together and then the sine of an angle. And I knew the angle had to be the one that's between the two given sides. So if I want to use this side and this side, I would have to use this angle, which they happen to have given me, right? So go ahead and calculate what you would get for the area. All right, please write 236.6. Looks good. So our area was 1/2 And then I knew it was 2 side lengths. You don't have to memorize it like this. This is what I do. We all know my memory sucks, okay? So I just know 2 sides in an angle, and the angle has to be the angle between 2 sides. That way I don't have to memorize A, B, and C, A, C, and B, whatever, okay? So here the 2 sides are 23 and 35, and the angle between them is 36. And then if we type all that into the calculator, we get 236.6. And we were finding area, so whatever the units were, which in this case wasn't given, they would be squared. So is that part okay? Just area from a different perspective. If somebody gave you the formula all put together instead of you drawing the altitude. Okay, so what was the purpose, right? I told you guys yesterday, the purpose of us starting with area was to get to a point where I could put the problems I put in front of you yesterday, and instead of saying find the area, I could say find all missing sides and all missing angles. First of all, were you guys able yesterday to find all the missing sides and all the missing angles? Look back at number 2 and number 3. In the work that you did to find the area, did you end up finding missing sides and missing angles of the triangle? Could you, if you had to, find all the missing sides and all the missing angles of that triangle? Yes. Okay, so again, what I'm going to show you is helpful, but if you ever forgot on a test, there are some ways that you could go about figuring this out with the prior knowledge that you have. Right? So basically, this is what the mathematician says. You're going to end up writing one more thing over here. Maybe I can fit it. Maybe I can't. I'll go an extra page. So we have those 3 formulas, right? They all 3 calculate the area of a triangle. So they say this. Well, if you know that, really bad. Okay. If you know that this calculates the area, but you also know that this calculates the area, and let's say they're equal to each other, right? Because they both calculate the area of the triangle. Fair enough? Okay, if they both do the same calculation, they must turn out equal. The triangle's not like shape-shifting or anything, right? It's like staying the same size. So if I wanted to simplify this, okay, first of all, I could cancel 1/2 out from both sides. If I divide both sides by 1/2, the 1/2 is gone. Okay. And I'm not saying we would think of what to do next. I'm telling you what mathematicians thought of. So they looked at this and goes, great, we have this formula. We could make it better if we divided both sides right now by A, B, and C. So their goal is trying to cancel these out, right? But they're kind of different. So they're going to use all the letters. So I'm going to divide by A, B, and C. So here the A and B are canceled out, but I'm left with C. Here the A and C are canceled out. Sorry, you guys, this was wrong. Okay. See how I used the letter that was different? Okay. But left with B. So I'm going to tell you guys what to write in a minute. You don't have to know how to derive this over and over again. But basically, it leaves us with sine C over C equals sine B over B. Okay. And then if I took the third area formula and I put that equal to it and I did the same thing, I would get that if I can use any of these, the third one would say sine of A over A. Okay. This is the law of sines. So up at the top where you drew the triangle and the 3 area formulas, you also want to write down this. So really the purpose of us looking at those area formulas was not to memorize new area formulas, but just to understand where they came up with this law. Okay? So this law is simple in one sense, but super difficult in another sense. Memorizing it, pretty simple. Because look, basically, the sine of any angle over the side that's across from it, right, can be set equal to the sine of any other angle in your triangle and the side across from it. Okay? And they're all nicely alphabetically compatible, so it's easy to visualize and see and memorize. The hard part about this law is what we're going to do next week. Sometimes people can trick you. They can give you information that may not even really make a triangle. It may make one triangle, or it actually could have 2 possible triangles that they could make. So the problem is not going to come with using this law. Using this law is going to be pretty simple. The problem's going to come next week when the situation gets a little more complicated. Thinking through at the beginning, what are they really giving me? Is there a triangle? Is there no triangle? Is there 2 triangles? And that's going to be the hardest part. Okay? Today we're only going to do like the straightforward ones where we know for sure there's a triangle, how to use this and solve it properly. Okay, so that part you guys will probably like, okay? And then like next week you'll be like, oh, this sucks, okay? But we'll work through it and we'll find a way to like analyze. We'll come up with a process that you guys can go through, okay? All right, so we're going to skip the try these and we're going to go here. So this looks similar to what you guys were given yesterday, right? I asked you guys to find the area, but now I'm asking you to solve the triangle. So what does it mean to solve the triangle? You have to understand the directions before you can do the problem. So what does it mean to solve the triangle? Good. Find all the angles and all the sides. Basically, every piece of information about that triangle, you need to figure it out. So, could you have done this yesterday? Look back at what you did yesterday in number 2. Number 2 was set up a lot like this, right? Almost looks exactly the same with different numbers, correct? Okay? You guys weren't solving, you were finding the area. But in finding the area, did you find out a bunch of stuff about this triangle? Could you have figured out everything that's missing from this triangle? Yes. Okay, you guys could have. So, if you get the quiz and you freeze and you don't remember the law of sines, can you do nothing? I mean, you could. I don't think that's a good choice. Okay? But you actually have, okay, the part of our purpose in doing the thing we did yesterday was to show you guys, you know some stuff. Just because I teach you something new, if you don't grasp it, don't be like, I know nothing. I did not understand what she said. You are a human being with a working brain, and you know some stuff. You've been in school for a long time. You didn't get here without doing anything, okay? So we're learning this new stuff, but if you don't quite grasp it, do what you can every time, right? So let's look at, though, how we would use this. And again, I think that you guys are going to find that this law is fine as long as you know you have a triangle. How do I know for sure this is a triangle and they're not tricking me? Do you guys remember from geometry your triangle congruence theorems? They were like these ones. Do you guys remember these? Okay, then there was like the bad word, right? For Miss Dahl, that's a bad word. Okay. For you guys, I'm sure is not the worst word you said, some of you. I've heard some worse words right here in this room. Believe it or not. No, I haven't never said a word worse than these, but it doesn't happen in my daily life. Okay. So, do you guys remember which ones here don't work? And so remember what these were for. These were basically if I tell you a side measurement, another side measurement, and a side measurement of a triangle I'm holding, and you're going to build a triangle that has those same side measurements, yours is going to be forced to be the exact same size as mine. That's what these were here to prove in geometry. If you have these 3 measurements, you have no other choice but to be the same size and shape as my triangle. Okay? But which ones didn't work? Angle, angle, side worked. Yeah. This one didn't work, right? What else didn't work? Angle, angle, angle. If I said everybody right now draw an equilateral triangle with 60-degree angles, some of you might draw little teeny tiny ones like this, some of you might draw really giant ones like this, right? It doesn't work. So those 2 didn't work because in giving you those measurements, there's actually here infinitely many ways someone could draw the triangle. Here, it's a little trickier. It's so close, but there's actually 2 ways that someone can draw the triangle if you give them this group of information. So theirs is like a 50% chance of being the same as yours, but not for sure. So in geometry, we say this can't prove that your triangle is the same as mine because there's this 50% chance they drew something different because there's 2 ways to draw. No, this one is saying I give you a side measurement, another side measurement, and I'm forcing how big your angle is between them. This one is saying I'm giving you an angle measurement. I'm telling you how long to make this side and how long to make this side, but I didn't tell you how long to make this side. And so that's where there might not be a triangle, because what if I tell you this has to be this long and this has to be this long, and this one's only this big? Maybe it doesn't reach all the way, right? And you're not allowed to change the angle, so you're kind of stuck. Okay? And so there's a couple different ways we can do that one. The rest of these work. So when I look at this triangle right here, the way that the information has been given, if I like rotate around the triangle, right, to name, I have an angle, and then the next thing I have is an angle, and then I have a side. So basically I have this, angle, angle, side. Okay? So do I for sure have a triangle? According to the geometry congruence postulates, yes, I'm good. So since I know there's a triangle, there's no problem. What we're going to study next week is this situation. That's why there's going to be a problem. But for all of these situations, we're good. We can just start. So your law of sine said this. If this is angle A, right, then this side across here would be side A. If this is angle B, then this side across here is side B. And this is angle C, and this side across here is side C. Okay? Your law of sines said this. The sine of any angle you pick, you can put it on top of the side across from it. It's equal to the sine of any other angle you pick and the side across from it. Okay? So basically, to use this law, I need one complete fraction, one complete ratio, meaning I need an angle and the side across from it so I have one thing that's all numbers so I can actually solve for stuff. Do I have that here? Yes. Okay, which angle pair do I have? A. So I have 40, and then I have the side across from it, 20. So I know here the sine of 40 could be put over 20, and that can be equal to the sine of this over this, or the sine of this over this. Okay? Do we know the missing angle here? Can you figure it out pretty quick? 80, right? Because 40 plus 60 is 100. Subtract that from 180, that's 80. So basically now I just make a choice. What do you want to solve for first? Side B or side C? C? Okay. So if I want to solve for side C, what should this fraction say right here? The sine of 80. Because if I'm solving for C, it's across from the 80-degree angle. So the sine of 80 over C. You might not like the way this equation looks, but this is solvable because everything is a number with one variable here that I can solve for. Right? So then we just have to do the arithmetic. Okay? So in my calculator, I can do sine of 40. Okay? We can also cross multiply. I'm going to do it without a calculator till the end because that's a little harder for you guys to see, so I'll do that here. So we can cross multiply because it's one fraction set equal to one fraction. So C can multiply sine of 40, so it would say C times the sine of 40. And remember, the sine of 40 is a number. You can type it into your calculator and get a decimal. And then 20 will multiply the sine of 80. So this will equal 20 times the sine of 80. What do I have to do next to get C alone and have it solved for? So do you guys agree with what Ben's saying? So here's C. To get it alone, I have to get rid of what it's multiplying by. Since it's being multiplied by something, I'm going to divide by that number. Okay? And that will cancel that out. Okay? And so then in your calculator, here's what you're going to calculate. What is 20 times the sine of 80? And then divide that by the sine of 40. Okay? And then you'll have your answer. So if we do that, 20 times the sine of 80, and then divide that by the sine of 40. And I get 30.6. Okay? So I get that this side length is 30.6. Am I finished solving the triangle? No. Okay? So I still have to find B. So how would you recommend that I go about finding B? Oops. What should I do? Okay, so sine B over B so that I can have B somewhere in the equation. So sine of 60 over B equals, somebody raise your hand and give me the other side of the equation. John. Good. So having that first ratio that was all set up, angle across from side, was key for us, right? Because once we have those numbers, it makes it a lot easier to solve for something else. And then I'm going to do the same steps to solve that I did last time. So these two will multiply and these two will multiply. So 20 times the sine of 60 equals B times the sine of 40. I'll divide the sine of 40 to get B alone. And then that's what I'll have to put into my calculator. So 20 times the sine of 60, and then divide that by the sine of 40. And you should get 26.9. Does anybody remember something from geometry that could enable you not to like check your answers like to the nearest tenth, but just to make sure that your answer makes sense? Do you guys remember any theorems from geometry that told you about the angle size and how that related to the side length of a triangle? So if a triangle has a really small angle in it, like let's say I made a really small angle, okay, and I was trying to make a triangle out of that. How big is the side across from that angle going to be? Not big, right? Because the smaller I make the angle, the shorter that side across from it has to be, or else the angle would be opened up too much. So in geometry, there is this theorem that says smaller angles should be across from smaller sides, and larger angles should be across from larger sides. So when I look at this triangle, the smallest angle should have the smallest side across from it. So is that true? It's 20, the smallest side length that we have. Yes. Okay. The biggest angle should have the largest side across from it. Is 30.6 the largest side? Yes. Okay. So that simple geometry rule is a really good checking mechanism. It doesn't make you go through all the algebra again, but it at least lets you know if your answer makes sense for the situation. Okay? So something little that if you remember can help you check your answers on a quiz or something like that. Okay? All right. So why don't you guys try to do part B? Okay. So somebody tell me an equation that they set up to try to solve for something for himself. Good. So notice what she used. So key in solving this for us, we need a pair that matches so we don't have too many variables that we're solving for, right? So once we had that pair, we could set it equal to any other angle side ratio that we wanted. But this was the only other number we had, so we were kind of forced to start here. Okay? So then I saw people solving, and for the first part, they were fine. They did the cross multiplication, and then they even divided by 63. Okay? But then here's where people started asking me a lot of questions. They ended up with this. Now, the stuff on the left looks crazy, okay? But it's just a number. I can type that all into the calculator and get a decimal. The reason, why do you think people were asking me questions when they got here? Yeah, because it's the sine of B. It's not just angle B. So think back to when we reviewed our geometry, triangle trigonometry. When you had an equation where you had sine, cosine, or tangent of an angle, and you needed to get that angle by itself, what operation was it that you were doing? The inverse. So the inverse sign would undo the sign and just leave me with angle B, but then the inverse sign would also have to be taken on this side of whatever this decimal was that I got. So you can actually type all of it into the calculator once, but most of you like calculating this first. So you can do 57 sine 42, divide that by 63 and get an answer. And then if you take the inverse sign of that answer, this is like 0.60540, something like that. Then you get that angle B is equal to 37.3 degrees. So that was a lot of work, and I might feel all happy, but I'm not done with the problem because I haven't finished solving the triangle. Okay. What piece of information would be easiest for me to find next? Angle C rather than side C right now, right? Because I have two of the three angles in a triangle. So if I do 37.3 plus 42 and then subtract that from 180, I get 100.7. Okay. So now I can set up sine of 42 over 63. Okay. That angle side ratio that I have is now equal to the sine of 100.7 over C. And then I'm able to solve for side length C. So then you'll type all that into the calculator and get what C is equal to, which should give you 92.5. And then I would do the quick check I was just telling you guys about, rather, because there's a lot of steps, right? So it would be hard to recheck my answer completely. If I have the time, I'll do it. Otherwise, though, I can quickly check. Biggest angle, biggest side. Smallest angle, smallest side. It seems like my answer at least makes sense, okay? Now, Ben made a good point to me as soon as we started this. He was like, Miss Dahl, this is totally the time when you said we couldn't necessarily do this. Because how was the information in this triangle set up the way that it was given to us? We were given, if we go around the triangle, right? Angle, side, side. That was the one that we said didn't necessarily work, right? So we made a big assumption that it worked, and right now it's okay for us to make that assumption, and as of Monday we won't make that assumption anymore. And then we'll figure out how this one actually worked, and when would it not work, and when would there be two things that you could make, and stuff like that, okay?